6 marks, combined science, chemistry, also triple science, obviously. 0.72 grams of magnesium is added to 100 centimeters cubed of hydrochloric acid. The hydrochloric acid is in excess. Calculate the concentration of the magnesium chloride solution produced in grams per dm cubed. We've got some relative atomic masses and we have a balanced equation for this reaction. So the magnesium chloride that we are being asked about is here, and the magnesium that we have been told about is here. The hydrochloric acid that we've been told about is here, but because the hydrochloric acid is in excess, we essentially ignore it for the purposes of this calculation. What they're trying to tell you by saying that this is in excess is that there's plenty of this, it won't run out. The 0.72 grams of magnesium, though, will run out, so that's what's called the limiting reactant, and that's what's going to cause this reaction to stop, which means that we can use that to determine the quantities of other chemicals in this reaction, because that's the one that's determining really how much we're going to produce, because that's going to get used up, and that's when it's going to stop. So how do we do this? Well, I always set these up in a very similar way, so I'm just going to zoom this out slightly, where I like to write down what they've told me about the mass of the substance that we are starting with, 0.72 grams. And then what I'm going to do is ultimately I would like to work out the mass of the magnesium chloride produced. I know that's not what the concentration says. The question says. It says the concentration. But that is how I'm going to work this out. I'm going to try and work out how many grams of magnesium chloride I'm going to produce. Once I've got that, I can work out the concentration using the volume. So how do we figure out how many grams of magnesium chloride we're going to produce here? Well, first what we're going to do is convert this to moles. The way you convert grams to moles is, if I just write this down on the side here, that moles equals the mass in grams over the relative formula mass, or the relative atomic mass of the substance involved. So in this case, what we're going to do is divide this by the relative atomic mass of magnesium, which is 24. 0.72 divided by 24. Remember, you have a calculator for everything, so 0.72 divided by 24 will give you 0.03. That is telling you that we are going to start with 0.03 moles of magnesium. Why is that helpful? Well, that's particularly helpful when you've got a balanced equation, because the numbers in front of the substances in a balanced equation are a ratio. They tell you how many moles are produced depending on how many moles that you start with in the equation. So for example, what we're telling you here is that if I've got 1 mole of magnesium, I would react it with 2 moles of hydrochloric acid and produce 1 mole of magnesium chloride and 1 mole of hydrogen. So the two things we care about, the magnesium and the magnesium chloride, are in a 1-to-1 ratio, which means that if I've got 1 mole of this, I will make 1 mole of this. If I've got 0.03 moles of this, I will make 0.03 moles of this. What we can do now, because we already know the relative formula mass of magnesium chloride, I'll just write that down over here, we can go backwards from moles back to grams by basically rearranging this equation. If we wanted grams, it would be moles times mR. So we've got moles, we've got the mR there of magnesium chloride, it's given to you in the question. If we multiply these together, you'll get the mass in grams of the magnesium chloride. So 0.03 times 95 tells me that we are going to produce 2.85 grams of magnesium chloride from this reaction. If the question had been work out the mass of magnesium chloride produced, that would be the answer, but that's not the question. The question wants the concentration of the magnesium chloride produced, and it says in grams per dm cubed. Now, there is a formula for concentration. Concentration equals the mass of the solute, which is essentially the solid particles in a solution, divided by the volume of the solution. Now, we know that we've got 2.85 grams of mass, because that's what we just worked out in this question. Now, we also know that the volume is 100 because centimeters cubed is a unit of volume, as told you in the question. The only problem with this is that we want the answer in grams per dm cubed. Now, there are 1,000 centimeters cubed in 1 dm cubed, which means that to get from here to here, I would need to divide by 1,000. 100 divided by 1,000, move the decimal point back 3 places, is 0.1 dm cubed. So what I need to use in this question is not the 100 centimeters cubed, but the 0.1 dm cubed, because only then do I get the answer in the units that I want, which are grams per dm cubed, according to the question. So 2.85 divided by 0.1 is, of course, 28.5. 28.5 grams per dm cubed is the answer to this question. You've got yourself 6 marks.